Good morning, everyone. Today we will do basically a review. So the floor is open for you. If you guys have any questions from the review, you can get started. So any question first about yesterday's homework before I go to the review? Zach, 11.2, number 3. Okay. So 11.2, number 3 and 8. Okay. Number 3. Zach, do you know what the problem is?
I'm opening MATLAB right now.
Because some of the problems I assigned this time, I forgot to write them down, are not from the book. It's from something called the test bank, because the problem that they have from the book were not the one I want. So I would appreciate it if you can give me the exact problem.
Yeah. So it's x minus 2 to the n over n squared 2 to the n.
Over n squared?
2 times 2n, or 2 to the n power, sorry.
That's it?
N squared times 2 to the n power.
Oh, okay.
Almost.
I'm sorry.
No, that's okay.
This one?
Yeah, that's perfect.
Yeah, even for problem 8, Kiana, if it's from the review, it's fine. If it's from the MATLAB, I mean, you have to tell me what the problem is. All right. So the question, I imagine, is the interval of convergence, right? So we use the ratio test. And we figure out first what an is and what an plus 1 is. So an is x minus 2 to the n over n squared 2 to the n. An plus 1 is x minus 2 to the n plus 1 over n plus 1 squared 2 to the n plus 1. And now the question is to basically find the ratio and use the ratio test to determine what's really going on. So I'm going to take r to be the limit as n tends to infinity of absolute value of an over the absolute value of an plus 1 over absolute value of an. So this will be equal to the limit as n tends to infinity of. All right, the first one is absolute x minus 2 to the n plus 1. The denominator is positive, so the absolute value does not play any role. But the numerator, it plays because x can be negative. Sorry, x can be less than 2. So like x could be 3. And this can cause this expression to be negative. So I have to take the absolute value. And down here, it's x minus 2 to the n over n squared 2 to the n. Now we have to flip things around as usual, and we get the following limit. And we arrange terms. So we will have, if we do this, over the x minus 2 to the n, and then I will have n squared over n plus 1 squared, because that's easy to find the limit. And then this will go up 2 to the n over 2 to the n plus 1. Okay. And now we evaluate this limit. The easiest way to do that, you can either take n plus 1 squared and expand it, but I think it's much easier to rewrite it this way, times. Now 2 to the n plus 1, of course, we've done this several times. This is 2 to the n multiplied by 2. It's multiplied by 2. So I will be left with 1 half. And here I will have x minus 2. Because for the same reason, this piece, we split it into x minus 2 to the n times x minus 2. Okay, and then I simplify. So finally, when n goes to infinity, this goes to 1. And this will be left with a half x absolute value of x minus 2. So this is what the ratio is. So now we argue, using the ratio test, based on the answer, we argue when the series converge or diverge. And so the ratio test now at this stage tells me if this quantity is less than 1, then we have convergence, bigger than 1, divergence, equal to 1, that's where the test is inconclusive and we have to do something else. So let us discuss. So by the ratio test, what do we have? The series converges when the ratio, which is this one, is less than 1, okay? And now what we have to do, this is less than 1. So first we actually solve for the absolute value of x. If this is less than 1, it means the absolute value of x minus 2 you multiply by is less than 2. Another question is for which axis is this is occurring, right? For which axis? If absolute x minus 2 is less than 1, it means what's inside it, this piece, the only this can happen if this is the maximum value this can take is 2, the smallest value is minus 2. It means x is between 4, I add 2 both sides, and 0. On the number line, x minus 2 is less than 2. It means basically, as I said yesterday, here it means x is between 2, this 2, plus 2, and minus 2 plus 2. So the way I'm graphing it is x between 2 and 2 here. So that's 2, 4, and 2, and you take away minus 2. So this is the convergence. And diverges when the ratio is bigger than 1. And this occurs outside this interval, means when x larger than 4 or x less than 0. So this is where the divergence occurs. Just always an interval. And the interval is always centered at A, which is the 2. So that's always is the center of the interval. Now finally, at the end point, it means at 0 and at 4. If x is 0, the ratio, if x is 0, watch, if x is 0, the ratio will be 1. It means the ratio test is inconclusive. So that's why we have always end up doing something else at the end point. So now the end point, x equal to 0. What do we do at this stage? We plug in 0 into the expression of the series. So my series was I plug in 0 into it. So I plug in 0 for x. I will have minus 2 to the n over n squared 2 to the n. And now it's this new series, which is a series of numbers. I have to decide whether it converges or not. Now minus 2 to the n, that's to make, we can basically rewrite that as minus 1 to the n times 2 to the n. So those are exactly the same thing. So this we can split it as minus 1 to the n times 2 to the n over n squared 2 to the n. Now those two simplify, and it means that the series become the following. Okay. So if I plug in 0 for x, I end up with this series. So the question, does this one converge or diverge, and why? So now it's a series of numbers, it's not x anymore. So now we go back to what we know about number. Does this series converge or diverge? Quickly. I'm listening.
Converge.
What?
Does it converge?
Because?
The alternating series test.
Exactly. It converges by the alternating series test. Okay, because the term here are 1 over n squared. The 1 over n squared definitely goes to 0. These are the positives, these are the absolute value of those. And definitely 1 over n squared as a sequence, this is decreasing. Because if n increases, n squared increases, 1 over n squared will going to be decreased. So converge by the alternating series test. Now for x equal to 4, I plug in 4 into the expression of the series. That's really what we're doing. And this would give me 4 minus 2 is 2 to the n, 2 to the n. This will become 1 over n squared. Now, again, I have a series of numbers. And the question is, does this new series of numbers converge or diverge? So it's 1 plus 1 over 2 squared plus 1 over 3 squared, and so on and so forth. Does this one converge and why? Again, back to you. Back to you. Does this converge or not?
Yes, P series.
That's a P series. Converges, that's a P series where the P is equal to 2. Okay, so the interval of convergence means of convergence is it converges at 0, it converges at 4, and converge everything everywhere in between. And the radius of convergence is usually, as I said, half the length of that. So the radius of convergence is equal to 2. So the picture now is that this series, means this kind of polynomial, that's the 2, and it converges between 0 and 4. And the radius is from here to here. That's the radius. Okay. Questions about this problem?
Yeah, I have a quick question.
Yes.
So for the power series, do we always use the ratio test, or is that just depending on the problem?
The ratio test, the ratio test. The book is using the ratio and another test called the root test. I want you only to use the ratio test.
Okay.
All right. Okay. Now, Kiana number 8. From where?
From the homework.
Okay, so I need the statement for it. I think you gave it to me at the end. I didn't see it. So it's sigma k x minus 4 to the k. And
K factorial.
oh, thank you. And the k, I think, can go here from 0 because there is no problem at 0 all the way to infinity. All right.
And we just have to find radius of convergence.
Radius of course. So to find the radius, we have to find basically, we have to do the whole thing. All right. So we cannot just find the radius. We have to do everything, and then we know what it is. All right. So again, here we have to find AK and AK plus 1. AK is k factorial x minus 4 to the k. AK plus 1 is x minus 4 to the k plus 1. And we have to find the ratio.
I have a question. Which number is this?
What?
Which number is this?
It's from the MATLAB homework.
It's number
okay.
8.
It's number 8 from the MATLAB.
All right, thank you.
And this time I could not give you, as I said, the same problem as in the book because, you know, MATLAB doesn't give me a lot of choices. He gives me some, I cannot assign anyone I want. It's not, they give me a bunch of problems. So I did not like what they gave me in terms of this type of series. So I went to their test bank to be able to give you a problem along those lines. But I don't have them with me. So is from their test bank.
Okay.
And
Thank
you
you.
should have the same variation. I mean, that's how it works. So AK plus 1 over AK. So it's the limit as k goes to infinity of k plus 1 factorial. So there is no really ratio here. Absolute value x minus 4 to the k plus 1 over k factorial x minus k to the power k. All right. And then, of course, we cannot keep it like this. We need to do the simplification as we always do. K plus 1 factorial is k plus 1 times k factorial, because we want to simplify, and we've done this. This will become x minus 4 to the power k, x minus 4, because we know we have to simplify by that. And this is x minus 4 to the k. Okay. So now we do the simplification, the k factorial, x minus 4, x minus 4. So I will have equal to the limit of k plus 1 times x minus 4. Okay. Now as k goes to infinity, this will be equal to what?
Infinity.
Infinity. What does this mean? That's the ratio.
It diverges, or
All converges.
What?
All converges.
No, the ratio is bigger than 1.
oh, so it converges.
Diverges.
Diverges, right? The ratio, regardless what x is, the ratio is bigger than 1.
Unless x is 4, correct?
Exactly. I was about to say that. It diverges all the time except for one value, for x equal to 4, and it's going to make sense why it converges for x equal to 4. Why x equal to 4? So if x is equal to 4, this is 0. So 0 times anything, it's 0. So it's bigger than 1 for all x's except x equal to 4. So because for x equal to 4, I have 0 times something, which is a 0. But as long as x is different from 4, this is bigger than 1. So what does this tells me about the series? It means the series will diverge. Diverges for all values of x except x equal to 4. And I repeat, why x equal to 4? Because if x equal to 4, I will have 0 times k plus 1, which is 0. So it will be less than 1. So x equal to 4 is special case. Otherwise, if x is different from 4, the series will always diverge. So what do you think the radius of convergence is going to be? Any hint? So it converges at 4, and that's it. That's it. Doesn't converge anywhere else. What do you think the radius of convergence is going to be? 0, absolutely so. The series doesn't converge, it diverges all the time. And let me give you a little idea why it's going on in here. Why the series is not converging for any terms. Just intuitively what's happening. The terms of the series are like that. So it's something like, okay, x minus 4 plus 2 factorial, x minus 4 square, plus 3 factorial, x minus 4 to the power 3, plus so on. 100 factorial, x minus 4 to the power 100. That's the type of series. The reason is that factorial goes to infinity faster than anything else. In other words, factorial, k factorial, goes to infinity very, very fast. Faster than the power. Very, very fast. If you evaluate 100 factorial and you evaluate, plug in any number here. If you take 100 factorial and plug in any value for x here, anything you can think of, let us pick x to be 6, for example. And then you will have 2 to the power 100. 100 factorial. So I put in 6 for x, just number off the top of my head. This number, 100 factorial, goes to infinity very, very fast. This number is huge, absolutely huge. There is no way for the series to converge. Those terms are going all the way to infinity. So k factorial goes to infinity very, very fast. Nothing really can control it. So when you are multiplying by k factorial, you expect those terms to go to infinity. That's what's causing a divergence all the time for this particular series. And that's because of the k factorial. Okay. So that's what's happening. It's an interesting problem because one of the few problems where the series never converge except at one point. And for x equal to 4, actually why it converges for x equal to 4, because if I plug in 4 here for x, I get 0 plus 0 plus 0 plus 0. That's what's happening at 4. So if you plug in 0 here, so x equal to 4, you get 0. So this is going to be equal to 0 for x equal to 4. That's why it's converging there. Once x is different from 4, everything collapses. Okay, questions before I move on to your review? All right, so I'll go through review one by one. So problem number 1, D1F from the review. All right, so we do number 1. Please ask questions. It's your chance to ask any question you want. So 1D and 1F. All right, so 1D. Remember to be very careful tomorrow or anytime. Sequence versus a series. Do not confuse the idea. Sequence is just a list of number, no more, no less. It's just list, we list them. Series, we add those numbers. It's a very different idea. So we add numbers, add them. Physically, we add more and more terms. Sequence is just a list. And we're asking whether this list eventually get close to something or not. Series, we add terms. So don't confuse those ideas. Problem number 1 is about sequences. It means it's only about a list of numbers. So number D, we have the following sequence. AN is N e to the minus N. And the question is, does the series converge? Does the sequence converge or diverge? So now I am not adding those terms. So now I am looking at this list. If N is 1, this is the list I'm looking at. 2, it's a list. I'm not putting a plus in between. So be very, very careful. I'm not putting a plus. That's only a list. 3, e to the minus 3. 4, e to the minus 4. I'm not adding them. I'm listing them. And the question is, when this term n becomes large, those terms, do they get close to anything? So let's do that. So it means you have to compute the limit as n tends to infinity of n e to the minus n. Okay. Now when n goes to infinity, what's happening? N goes to infinity, that goes to infinity. What about e to the minus n? It goes to where when n goes to infinity quickly? And
Infinity, but a lot faster.
what? Two of
We'll
you.
go to infinity in the denominator.
Yeah, e minus n is basically 1 over e to the n, right? So as n goes to infinity, 1 over e to the n goes to 0, because e to the n goes to infinity 1 over it, so this will go to 0. So this will now basically go to 0. And now we know that infinity times 0 is indeterminate. So to be able to find the limit, we have to put e minus n in the denominator. So this is going to become n over e to the n. And now what is the limit of that? Okay. As n goes to infinity, infinity over infinity, I can use L'Hopital's rule. And that will give me the limit. Derivative of the numerator is 1. Derivative of the denominator is e to the n. This is going to be equal to 0. So the limit is equal to 0. Remember, that's the sequence. I'm not adding those terms. Those are individual terms. I'm asking myself, what happened to those individual terms when n becomes large? Okay. Now I look at f. So this is D, f. F is an equal. Again, that's a sequence. That's a list of numbers. 9 to the n over 10 to the n. And what's the limit of that as n tends to infinity? So again, I'm looking at the following. 9 over 10, comma, 9 squared over 10 squared, comma, 9 to the power 3 over 10 to the power 3, comma, 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 etc. All right. So what's the limit of that? Okay. All right, back to you now.
Can we rewrite it as 9 over 10 to the power of n?
Absolutely correct. We rewrite it as 9 over 10 to the power n. And now what's the limit of that as n goes to infinity? Back to you. We've seen this, I mean, I'm sure. What happened to this as n tends to infinity?
Goes to 0.
Because what did we see? This term, what's specific about this term?
Is less than 1.
Right, less than 1. In absolute value, of course, this term is less than 1. And we've seen in class that, and intuitively, if you have a number less than 1, and you start raising it to a higher and higher power, the number gets smaller. And so 9 is, so it means that 9 over 10 to the power n goes to 0 as n goes to infinity. Okay, so remember in class we saw the following. So let me remind you what we saw in class. Suppose if r is strictly less than 1, so if you have a number less than 1, so the limit of r to the n as n goes to infinity is equal to 0. If r is bigger or equal to 1, then the sequence r to the n diverges. All right, so that's a fact that we saw, and we explained it a little bit in class, that if you have a number, if it's less than 1, when you raise to a higher power, the number goes to 0. If bigger or equal to 1, things diverges. If r equal to 1, then you will have basically 1, 1, 1, then the limit of Rn is equal to 1 because it's 1, 1, 1, 1. So this is my apology at this stage. Okay. All right. Questions about this problem before I move to what's next? All right. So I'll move Christopher number 2 from the review. 2 and 4 from the review. So let's look at number 2. Number 2. All right. So the idea number 2 is to remind you always what the series is. So I have a series, sigma ak, k equal 1 to infinity. So it means I'm adding a bunch of numbers. That's addition. That's addition now. So some students are still writing comma here. I haven't taken points off yet. Next time I will. When you have a series, it's not a comma between them. It's a sum. It's a sum. So be very careful with your writing. And it tells me that the partial sum is equal to 3 minus k, 2 to the minus k. Okay, so that's the partial sum. All right, it means that they did not give me the term, but they tell me if you start adding them, that's the formula for the partial sum. And the first question is, what's the sum of all the AK? Okay. All right, ideas. If they give me the partial sum, how can I find the total, the whole sum of the series? Let us interpret that. What does it mean Sk is equal to that? It means what is S1? What's the first term? What's S1? 3 minus, I put in 1 here, 2 to the minus 1. What is S2? That's really what it means. S2, it means A1 plus A2. That's really what this is telling me. It's equal to 3 minus 2 times 2 to the minus 2. That's how I interpret that. What is S3? It means A1 plus A2 plus A3 This is equal to, according to them, 3 minus 3 times 2 to the minus 3. That's how we interpret that. So they are giving you a formulas for the partial sum. And they are telling you find the total sum. How can I find the total sum? What's the relationship between this and that? Back to you. What's the actual sum?
Is it the limit of SK?
It's the limit of SK. SK goes to infinity. Absolutely correct. Because that's really what the sigma is. So it's nothing more than you take those partial sums and you ask yourself, what happened to the partial sums when k goes to infinity? Perfect. Now we have to find the limit. Okay, so the problem is a little bit abstract, but the goal of it is to remind you that that's what this sum is actually what happened to the partial sums. So if I give you the formula for the partial sums, you have to be able to give me the sum itself. So now let us evaluate this. Of 3 minus k to the minus k. Now again, this is a scenario. This is like the limit I did a minute ago in the following sense. Okay, this is going to become k over 2 to the k. Okay, and now what happened as k goes to infinity? 3 is 3. K over 2 to the k, what's the limit of that? So let me do it on this side. So limit as k goes to infinity of k over 2 to the k. This is the limit of infinity over infinity. If I apply L'Hopital's rule, it will give me 1 over 2 to the k, which is equal to 0. So now as k goes to infinity, this goes to 0. This is equal to 3. So it means that the sum, which is, I don't know what the terms are, but based on, I don't know what the terms are so far, based on the partial sum, this is equal to 3. Okay. Now, the second part of the problem is, that's the sum. Part B is find the terms. So if I give you the partial sums, can you find the terms themselves? Anybody?
Why don't we just plug in 3 to all of them then? To the original equation?
If each one of them is 3, what will happen to the sum? 3.
Oh, it goes
3.
infinity.
Right, right. Their sum is 3. How can
You said
I
it equal to 3?
What?
You said it equal to 3?
The sum equal to 3, not each AK. I don't know what the, we're going to find them. The sum is equal to 3. It means as you start adding, you should get 3 eventually. That's the sum, not the AK. The AK are the terms. They can't be 3. If each one is 3, their sum is infinity. Okay, I will show you the picture again, and I want you to be able to figure it out. So S1 is A1, right? That's S1. S2 is A1 plus A2. And they give me the formula for it. So this is equal, according to them, 3 minus, so that's the formula. Let me rewrite it here so we will be clear. S sub k, it means the sum of the first k terms is 3 minus k, 2 to the minus k. So S1, which is the first term, is going to be equal 3 minus, if I put 1 here, 2 to the minus 1. So that's the first term. A1 plus A2 is, according to the formula, 3 minus 2 times 2 minus 2. If I use S1 and S2, can I find A2? It's easier than you think.
So you're just subtracting S1 from S2?
Right. If I take S2
Okay.
minus S1, I'm actually going to get A2, because what's the difference between S1 and S2? It's just A2. So I know A1 from the previous one, which is S1. I can figure out A2. So A2 is going to be nothing more than S2. Take away A1 if you want, which is nothing more than S1, because A1 is S1. Okay, what about S3? It's A1 plus A2 plus A3. Now, A1 plus A2, this is S2. So A3 is nothing more than F3. You take away S2. That's how the sum is working. So in general, what is SK? I don't know if we seeing the pattern. Is A1 plus A2 plus etc. A to the k. But the first before AK is going to be AK minus 1. So what is SK? SK is SK minus 1 plus AK. So that's the difference between them. So what's the difference between the first K, the sum of the first K term, and the sum of the first K minus 1 term? The sum of the first K term is the sum of the first K minus 1 plus the last term. So what is going to be AK is the sum of the first K term minus the sum of the first K minus 1 term. Now I have a formula for that. I have a formula for this, and I have my AK. So I'll finish it very quickly now. So AK is SK, which is 3, minus K to the minus K, minus SK minus 1, which is 3, minus K minus 1, 2 to the power minus K minus 1. So basically, it's going to be equal to the 3 and the 3 simplify. So that's minus K over 2 to the K plus K minus 1 over 2 to the K minus 1. That's the AK. And the important part here is actually this relationship, that AK is the sum of the first K term minus the sum of the first K minus 1 term. And then we do the math and we evaluate it. Right. Part A is the important part because it reminds you over and over that the sum of a series is the limit of the partial sums, which is going to be equal to 3. This doesn't mean every term is 3 by any stretch of the imagination. The sum, if we keep adding, we get closer and closer and closer to 3. That's what this means. All right, so this takes care of which one I am at. 2, and now number 4 in the review. Number 3 is geometric series. Make sure, for me, those geometric series are not hard. Make sure you review geometric series. I will give you one of them. I'll definitely have a geometric series. Number 4 is the following. I will read it. We have a ball. It's dropped from a height of 100 feet. Okay, so you drop a ball from a height of 100 feet. Each time it hits the floor, it rebounds to 2/3 its previous height. Find the total distance it travels before coming to rest. So basically, we imagine it keeps going forever, and you have to find the total distance. So let us show what's really happening. So you take the ball and you throw it 100 feet. Okay, then this ball, so it goes down. The ball is going to rebound 2/3 of the 200. And then it's going to hit the ground again. So right now it's at 2/3. So if this is 100 here, that's going to be 2/3 of 100. Then it hit the floor, then it go back 2/3 of what it was. And then it hits the ground again. Back 2/3 of what it was, and it hits back again. 2/3 and go down. So that's a bouncing ball. 2/3 it come down. 2/3 come down. 2/3, 2/3, it keeps going. And what's the total height? All right, what's the total height? Equal to. First, you drop it 100 feet. That's 100. And then 2/3, so it bounces up 2/3 of 100, and then it go down. So it bounces up 2/3 of 100, but it's 2 times that much because it goes up and it goes down. Plus, right now we are here. It's 2/3 of what it was. So 2/3 of this. So basically I need to multiply this piece by 2/3. So it's going to become 2/3 of that will become 2/3 square. And there is a 2 because it's going up and down. That's where the 2 coming from. Plus, again, it's going to rebound the 2/3 of that. So we have to multiply this by 2/3. So this will give me 2/3 to the power 3 times 100 because it's 2/3 of what it was. But then you multiply it by 2 because it's going up and down. So far, I took care of that piece, 100, 2/3, 2/3 of it, 2/3 of it. But the idea is that it's going to keep going forever like that. I didn't get how you got the 2. Yeah, the 2 is because the ball is going up 2/3 of what it was, but
Okay,
then it's coming
now
down.
that makes sense. That makes sense.
Yeah, then it's going down. That's where the 2 coming from.
Okay.
And this is going to keep going forever. So this term is going to be twice because it's going to go up and down. And 2/3 of that, which is 2/3 to the power 4 times 100, plus etc., etc., etc. That's really the picture. Now, what type of sum is this? What type of sum is that? Kind of. Anybody? It is geometric, but it's not geometric starting from the first term. It's geometric starting from here, because from here to here, because of this 2. From here to here, you multiply by 2/3. From here to here, you're multiplying by 2/3. From here to here, you're multiplying by 2/3. The only problem I have is that the first term, because it's not going up and down, you don't multiply it by 2/3. So the way this is going to be equal, so the 100, we evaluate it by itself. And then the rest, this is geometric. So that's the piece is geometric. And the ratio is 2/3 because I'm multiplying here by 2/3. So what's the sum of the geometric series? It's the first term, whatever it is, that's my first term, times 1/1 minus the ratio, which is 2/3. So it's going to be equal to 100 plus 4/3 times 100 times, this will give me 3/1 because common denominator. The 3 and the 3 cancel out. I will get 500 feet. Means if this ball bounces forever, it cannot exceed 500 feet. So you drop it, go up and down, keep going forever. That's how you imagine will never exceed 500 feet. End of the problem.
What lesson did we do these problems on?
That's a geometric series. That's basically geometric series with a little bit of.
Okay, I see.
That's a geometric because every time is 2/3 of what it was before, 2/3 of what it was before. And that's how geometric series is, because how does geometric series work? You start with a term, and then what do? You multiply it by a ratio. You see what I mean? How do we move? By the same ratio. That's how the geometric series starts. You start with something, then you multiply it by r. So it's r times the PG of 1. And that's really what's happening here. After you drop it first, then what's going on? It's 2/3 of what it was. That's the r. 2/3 of what it was means you multiply by 2/3. 2/3 of what it was, you multiply by 2/3. So that's purely geometric series starting from the first term. just because there is no bouncing up and down at the beginning. That's the only reason. Answer your question? Okay. All right, so this takes care of that. Where am I now? 2 from the review. No, wait, I'm up here. 2 and 4, it's done. 2 from the review. Hazem, what do you mean by 2 from the review?
I already like you solved it. I asked it before you did it. That's why.
Okay, okay. Any other questions from the review? I don't see anything that I didn't answer yet. All right. So, okay, so I do the first, which is good because that's the beginning, which is you guys, some of you has forgotten. And then number 5 is a typical alternating series. And the only thing I can tell you about the alternating series that how to find an upper bound, and that was the mistake that came up on your quiz. So when I ask you to find an upper bound, let's tell you how it works. Suppose we have F3. So F3 is you're adding the first 3 terms, whatever they are. I don't know what they are. So suppose I call them A1, A2, A3. I call the first 3 terms. Then the error is always less than the first terms you neglect after A3. So it's going to be less than A4. The first term you neglect. So when you write S3, when you write the sum, so let us say you write A1 plus A2. I don't know what A1, A3, A4, etc. It has to be alternating. The error is, if you want to approximate with A3, the error is less than A4. The first term you neglect after your sum. If you want to approximate with S4, the error will be less than the first term you neglect after that. That's how this error is going to work. Now, number 6 is a bunch of series that in my review, I'm sure in the answers, I think I told you which test to use, just to give you an idea. The idea is to figure out which test to use, not only that, and how you apply it. So if you tell me limit comparison test without any explanation, I will not accept it. You have to tell me why it is also applicable. It means why the ratio is not 0 and is not infinity. So this is for number 6. Number 7 is about absolute conversions, conditional conversions, or diversions. So usually we take any problem. Suppose I take this problem and how we should answer it. The first part you do absolute. So you take it in absolute value and you decide, does it converge or diverge? If it converge, you're done. Because if it converges with absolute value, it will converge even without them. If it doesn't converge in absolute value, then you move on to conditional. And you ask, does it converge without absolute value? So like the first problem, in absolute value, you're going to end up with that. In absolute value, which eventually will diverge because this will behave like 1 over 3n, which is divergent. Then once you do that, if it diverges, then you say, okay, I have to take it without absolute value. At this stage, you're adding and subtracting, then there is a hope that this will converge, and this will converge because of the alternating series test. So this will become a conditionally convergent. Now, this series, again, you do the same. Start with absolute value, and then you move on. If you take this series, you try it in absolute value, it will converge by the ratio test. You're done. You don't have to move on any further. Now, 8, 9, 10, 11, you will definitely have problem along those lines. I mean, I'm telling you already. So make sure you go over Taylor polynomial, what's the formula for it, and how we use it to estimate the error. Okay, so definitely you will have problems. I mean, you will have problem along everything. It's not a lot of material. You will definitely have a Taylor polynomial. So put the formula in front of you. So during the exam, you don't have to go and start looking for it. So make sure you have that. And finally, the conversions. That's what I've did today and yesterday. Again, you will have problems along those lines. Usually students don't have difficulties with number 12 at all on their exam.
I have a question real quick.
Any question you want.
For number 7, when does it become conditionally divergent? How does that work?
There is no conditionally divergent. we don't use that word. It's either absolutely, conditionally, or divergent, pure and
Oh,
simple.
divergent. Okay.
Pure as simple. There is no conditionally divergent. Doesn't
Okay.
make sense. So this
I have a
one,
question.
this one will diverge, pure and simple, because the terms, if you think about them, it's n squared over 3n squared plus 1. They will go to 1/3, which is not 0. So this will diverge, simple.
I have a
Okay?
question real quick.
Yes, of course. You guys take your time, not in a hurry. Ask any question.
So for 7A, I started by testing for just regular convergence with alternate series test.
Yeah. Then you will find it
And
convergent.
yeah, I got convergence. How would you go about testing for absolute convergence and after that?
You just take it in absolute value. It means you look at this series.
But I thought we already took the absolute value
No,
for.
you took it alternating here.
Oh, then wait. But I thought during alternating series test, you have to make it an absolute value also.
No, the alternating series test, you're not taking an absolute. What you're doing in absolute value is you're looking at the terms. Those. And you're making sure those terms go to 0 and they are decreasing.
Oh, okay. So then after that, you take
Then
one.
you can, yeah, once you, then the alternating series test that tells you that if those terms satisfy those conditions, when you add them and subtract them, the series will eventually converge. Okay, remember the picture I tried to draw, I drew in class, that why this is happening, because let us say this is S1. You take away a term from it, and then you're gonna add term. That's what's happening in the alternating series. So you add less, then you take away, then you add, and you take away, then you add, then eventually you're gonna get somewhere. So the reason the alternating series test works is because you take A1, then you subtract A2. Then you add A3, you subtract and add. That's why this is conversion. So the adding and subtracting play an important role why the alternating series tests work. Chris, are you following a word I say?
Yes.
Yeah.
Well, I'm thinking